All right, guys, the goal of this video is to develop the unit circle, and here's what that means. That means three things. When we leave, when you're done with this lesson, you will know every single angle marked on this picture, so you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 terminal sides of angles. Every one of those represents, for example, you already know that that's 90 degrees or pi over 2. So the goal when we're done here is for you to see what the measure of all those angles are in degrees and in radians. So to know all the angles in this diagram in degrees and in radians. And I'm going to give you ways to kind of memorize them. Because at first it's overwhelming. It seems like a lot, but after you've seen the same patterns for a couple days, you'll see, oh, there are lots of quick ways to memorize it. So I'm going to show you those quick ways to memorize. So every angle in the unit circle, those are the important angles. And all of these angles, and we're going to explore this in a minute, they are all multiples of 30, 60, okay, or multiples of 45 degrees. Okay, so we're going to kind of explore that in a minute. But then you also need to know every single one of these points you will commit to memory. You'll know what the x value is and the y value is of every point, mainly in the first quadrant, but then they correlate to these points in the second quadrant, these points in the third quadrant, these points in the fourth quadrant. Okay, and just to remind you, this is a coordinatized unit circle. So the center is the origin. This point, because the radius is 1, remember it's a unit circle. This point is 1, 0. This point is -1, 0. This point down here is 0, or is 0, -1. And this point is 0, 1. So those are the easy ones, but all of the other points are going to be some weird fractions and or square root, and we're going to see where those numbers come from. All right, so just to recap, all points. So for every single angle that on the unit circle that is a multiple of 30 degrees, 45 degrees, 60 degrees, you're going to know them all in degrees and radians, and you're going to know that every one of those angles correlates to a point, and you're going to know the points. So that's our goal today, is to see all that information, and then it's going to be a lot of information, and then over the course of a couple weeks become really good at cranking those values out. Okay, so the first angle we're going to explore is 30 degrees. Okay, and I'll only show you this one time. From here on out, you're just going to commit it to memory, but I do want you to see that for this angle 30 degrees on the unit circle, there is a point on the unit circle. And I don't want you to think that number, those two numbers that we're about to find just fell out of the sky. They actually come from somewhere. So I'm going to drop a right triangle. Okay, this whole proof, I'm literally going to prove numerically what this is. So I want you to see that this is a proof I'm going to do one time. I'll never do it again, but it's here in the video. So I know that this length is 1. Okay, now I'm going to extend this down. I'm going to double this side length and connect it over here. So I'm basically going to take that triangle and reflect it. So now I know that this angle total is 60 degrees. So I now have a 60-degree angle in this red triangle. I also know, and this goes way back to geometry, that in a right triangle, this angle is 90 degrees. That means the other two angles add up to 90. So if this little angle is 30 degrees, then this angle over here is 60 degrees. So I know if this angle is 60 and this angle is 60, then this angle is also 60 degrees, which means the red triangle that I've just drawn, the large red triangle, is an equilateral triangle, which means that side is 1, this side is 1, and the entire length of this long side is 1, and we cut the angle in half, which cuts the side in half, which means that this side is 1/2. So right now we're looking at this triangle. 30 degrees, 60 degrees. This side is 1. This side is 1/2. So if I'm going to find this point on the unit circle, I need to find the x value, which takes me to the right, and the y value, which takes me up. So I already have the y value of the point. Okay, so always and forever, I need you guys to know this will never change. If the angle in the unit circle is 30 degrees, then the y value on the unit circle will be 1/2. That's never going to change. So you're going to commit these to memory, but I want you to see where they came from. Now, Pythagorean theorem, one time, never again. I don't know what this one is. I'm going to call it B. But I do know that 1/2 squared plus b squared equals 1 squared. Okay? 1/2 squared is 1/4. 1 squared is 1. Subtract 1/4 from both sides. That gives me that b squared is 3/4. And then I take the square root of both sides. And the square root of 3/4 is the square root of 3 over the square root of 4, but the square root of 4 is 2. So I know in a 30, 60, 90 right triangle that is embedded in a unit circle, the long side, the long leg, which we just found, is always root 3/2. And the short leg is always opposite 30, which is always 1/2. Okay? Now, I'm gonna leave this alone for now, and we will come back to it later, but the most important thing about this is 30 degrees correlates to that point. Okay? Now, second proof. Now I'm going to bypass, we have 30 degrees, we have 45 degrees, we're going to come back to 45 degrees. The other angle, you notice there are like 3 spokes in the unit circle. The other angle that we're going to focus on is 60 degrees. So these 3 spokes correlate to 30, 45, 60. So in this triangle, the large angle at the down here is 60 degrees. So for a 60-degree angle, the question is, what is this ordered pair? Right? Because I want to find all of the angles and how they associate to the ordered pairs. Well, y'all, this is the same triangle we did a minute ago. So I'm going to relabel it. If this is 1, opposite 30 must be 1/2. I mean, it's the same triangle from a minute ago. All we've done is taken this triangle from a minute ago and we've just reoriented it. It's the same triangle. It's congruent, just in a different orientation. So I know that the short leg is 1/2, and I know that the long leg is root 3/2. So now my coordinates are 1/2 and up root 3/2. So we've already found this point, and we've already found this point. And just to kind of give you a heads up, any angle that references 30 degrees or references 60, any angle that references 30 degrees or 60 degrees, whatever that means, is going to involve 1/2 and root 3/2 over and over, and you're going to see that. Okay, so we now have one point in the first quadrant, a second point in the first quadrant. Now, that takes us to the angle that's kind of in the middle. That angle is meant to be 45 degrees. Okay, so we have we have 30 degrees, 45 degrees, 60 degrees. So right now we are only focusing on 45 degrees. So here's my right triangle. Now the nice thing about 45 degrees, I think it's the easiest of them all. The 30s and the 60s can kind of be a lot to kind of make sense of, but 45 90. If this angle is 45 degrees, then this angle is 45 degrees, which means that the x-coordinate and the y-coordinate, which is the base and the height, will be the same. So I'm going to draw the diagram over here. We have 45, 45. I'm going to call this B. Well, this is also B. They have to be the same. Remember, think of a 45, 45, 90 right triangle as like a half of a square. So I know that B squared, remember now, we're only going to do this one time. We will never do this again, but I want you to see where these numbers come from. They didn't fall out of the sky. B squared plus B squared is 2B squared. Divide by 2, and you get 1/2, and then you take the square root of both sides. So the square root of 1/2 is the square root of 1 over the square root of 2, which is just 1 over the square root of 2, but then I have to rationalize. 1 times the square root of 2 is the square root of 2. Root 2 times root 2 is 2. Bow! So for any 45, 45, 90 triangle inside a unit circle, that means the base is root 2 over 2. That's my x-coordinate to the right. Y value is up. Okay, so 45 is nice because the x-coordinate and the y-coordinate are the same. So let's recap. You need to know that this angle is 30 degrees, which is pi over 6. Okay, you will commit that to memory. That's a big one. This angle, all right, it's 45 degrees. That's my terminal side. That is pi over 4. You will commit that to memory. Pi over 4, 45 degrees. The bigger angle in the first quadrant is 60 degrees, which is pi over 3. So those are all the angles in the first quadrant that you need to commit to memory, and the coordinates. So the coordinates are root 3 over 2, 1/2. Therefore, this one is 1/2 root 3 over 2. And then this one is just root 2 over 2, root 2 over 2. This one is, of course, 1, 0. This point, of course, is 0, 1. And, of course, we're at the center here, the origin. Okay, so it is, I just want to show you a pattern. This helped me, and I didn't see this until I was in college, and I'd been doing this for a couple years. Your x values, right? Think of your x value. At 0 degrees, your x value is 1. You're way out here. And then your x, as you move up on the circle, your x values, so my x values are getting shorter and shorter and shorter. So the pattern is, you start at 1, then your root 3 over 2, then your root 2 over 2, then your root 1 over 2, or 1 over 2, and then your x value is 0. So that makes sense. As you move along this circle, your x values are getting smaller and smaller and smaller as you move toward this point. And your y values are doing just the opposite. Your y values start off at 0, and they go up 1/2. So think of that as the square root of 1 over 2, then the square root of 2 over 2, then it's higher, square root of 3 over 2, and then, believe it or not, this is the square root of 4 over 2, and the square root of 4 over 2 is 2 over 2, which is 1. So there is that pattern. Square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. So there are a lot of patterns floating around in this. Now, here's the nice thing. If you know the first quadrant, then you can basically just manipulate to find everything else in the unit circle. So you know everything at this point. And just to remind you, this angle is, of course, 90 degrees, which is pi over 2. So really, and this is 0 degrees or 0 radians. Okay, so you know all those angles. All of those angles you're going to commit to memory. All of those radian angle measures you're going to commit to memory, and all of those points you're going to commit to memory. That's our goal, is to know the unit circle angle-wise and point-wise for those 30s and 60s and 90s. Okay? All right, so that takes us here. So now that we know everything in the first quadrant, I want you guys to see what I call the reference 30s. This is why reference angles matter. So I'm going to call this reference of 30 degrees. Okay, so every one of those dots represents two things, an angle measure and a point on the unit circle. So of course this is my 30-degree angle, which is my pi over 6. This angle is going to be 180 minus 30, which is 150. 150 has a reference of 30 degrees. This is why reference angles matter. Okay? If I go to 180 and I add 30 degrees, that's going to give me 210. It's important to know that 210 has a reference, right? 210 has a reference of 30 degrees. Also, if I go all the way 360 and subtract 30, that leaves me 330 degrees. So every one of these angles that I've labeled here have a reference of 30 degrees. I'm going to make a little a little rectangle. This helped me a lot when someone finally showed me this. It was in college. Wish they'd shown it to me in my junior year. Okay, so every one of those angles have a reference of 30 degrees. Now watch this. Pi over 6, this is 5 pi over 6. 210 is 7 pi over 6. 330 is 11 pi over 6. Now if you're like, how do you know that? That's fine. You can take those degree measurements and convert them to radians on your own. But I want you to know this. Every single time you see something pi over 6 as an angle, it's going to reference 30 degrees. If I give you a reduced fraction, if I give you 121 pi over 6, that is going to automatically be one of these four angles when you find the coterminal angle. Okay, so I just want you to know that if it's over 6 simplified, it's going to be one of these four positions. Okay, so that's why I think of reference angles being so important, because when I see pi over 6 in any form, that lets me know I'm in one of four positions. So that gives me kind of some context. Also, the points. We're going to use the geometry. This point is important to know. Root 3 over 2 and 1/2. Okay, well if I go over here, that's simply negative root 3 over 2 and 1/2 in the second quadrant. And if I'm in the third quadrant, it's negative root 3 over 2 and negative 1/2. Negative root 3 over 2, negative 1/2. And then this point is root 3 over 2, negative 1/2. I'm sorry, positive root 3 over 2. So the nice thing is I call all of those 4 points and those 4 angles, they are all reference 30 degrees. 30 degrees from the x-axis, 30 degrees from the x-axis, 30 degrees from the x-axis. That's why reference angles matter, and that helps you kind of compartmentalize those 4 points on the unit circle. Okay? Now, you are not going to know all that when you're done with this video, but after you spend a couple weeks just running through a ton of practice problems, you'll start to kind of really use some of these patterns, and I just want you to see them. You can always come back to this video, or you can take a picture of this slide and you can always come back to this slide, but there's a lot of good information on this one slide. Okay? Boop. Next slide. Reference of 60 degrees. Let's change the color. So reference of 60 degrees. So I've got 60 degrees. I've got 180 minus 60 degrees, which takes me to 120. I've got 180 degrees plus 60 degrees, which takes me to, what is 180 plus 60? 240. That's the one that gets a lot of people, by the way. This one's just a little wonky. Then you have 360 minus 60, which takes you to this angle, which is 300 degrees. Now, in my opinion, to this day, my reference 60 angles, let me draw another rectangle so we can use some symmetry here in a minute. This is where most of my mistakes happen. I'm just going to tell you point blank, if I'm cranking through a bunch of problems, I'm going to mess up a little bit here sometimes if I'm not careful. So 60 degrees is pi over 3. I call my reference 60s something pi over 3, and you'll see what I mean in a second. So if you convert 120, it will be 2 pi over 3. If you convert 240, that's going to be 4 pi over 3. And if you convert 300 degrees, that's going to be 5 pi over 3. So every single simplified radian value that is something pi over 3 is going to be a reference of 60 degrees. It's going to be one of these 4 points on the unit circle. So if I give you 1017 pi over 3, if that is actually reduced as a fraction, something pi over 3, then it's going to be one of these 4 values when you convert using terminal angle, manipulation. So these points, 1/2, 1/2, and root 3 over 2. Remember the taller side. If it's taller, it's root 3 over 2. If it's shorter, it's 1/2. So that means if this is 1/2 root 3 over 2, then this point is going to be negative 1/2 root 3 over 2 in the second quadrant. This point is going to be negative 1/2 negative root 3 over 2. So remember, third quadrant, both coordinates are negative. And then 1/2 up is now 1/2 down. That's going to be 1/2 down root 3 over 2. Those are the tricky ones. So just know that these two angles are the same. 240 over and 4 pi over 3, same. 5 pi over 3, 300. Those two are a little tricky, so that's just kind of make a note of that. Those tend to give students fits. So that gives us all of my points that reference 30 degrees and their corresponding angles. All of my points that reference 60 degrees and their corresponding angles, and that takes us to the easiest, I think the easiest. 45 degrees, reference 45, reference 45. Those middle angles, reference 45. So this angle, once again, 45 degrees, or pi over 4, root 2 over 2, root 2 over 2. So I call these reference. These are, well, I call them, they are. Every one of these angles has a reference angle of 45 degrees. So if I go 180 minus 45 degrees, that's an angle of 135. These are easy to spot because these are the only numerical values in the unit circle, angle degree-wise, that end in 5. So 45, 135, 180 plus 45 takes me to 225. 360 minus 45 takes me to 315. So these three angles have a reference of 45 degrees, and then, like the other pattern, they will always be something pi over 4 in reduced form. So 135 is going to be 3 pi over 4. 4 pi over 4 is pi. 5 pi over 4 lives here. 6 pi over 4 reduces. 7 pi over 4 lives here. So you have 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Those are your radian angles that reference 45 degrees. So the beauty is, if I give you something pi over 4, you're already thinking that has something to do with 45 degrees away from the x-axis. Okay, so we're going to use that same symmetry. root 2 over 2, root 2 over 2. So now I'm going to move left and up. So left and up, the same distance. Left and down, both negative, 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 and then positive to the right, and down is positive, negative. Okay, so I wanted to help you kind of compartmentalize all of this information. Now, you don't have to do what I just did. You can just, if I give you a blank unit circle and say, go, label all the angles in radians and degrees and label all the points, you can do that any way you want to, but I do want you to think there was a reason for reference angles. And there was certainly a reason for coterminal angles, which we'll see in just a minute. Okay, so I have now, in 25 minutes-ish, shown you everything you need to know about the unit circle. So, you now know every single one of the points, every single one of the angles in both degrees and radians. Now I say you know that, you're going to know that. You've seen kind of where all those numbers come from. Alright guys, so I've just thrown a lot of information at you. If you want to go take a quick jog down the street, walk, do some calisthenics, or just keep on grinding through, that's just a ton of information concept. Now we're just going to crank through problems very similar to what you've already seen in class. So now we're getting into the trig functions. Now I can use those angles and those points to actually find information about the trig function. So given angles, right? So we have coterminal angles. So just kind of walk through this. I'm going to give you a bunch of angles. If the angle is not one of the angles we've already discussed in this video, we're going to have to use the concept of coterminal angles, and we'll do that in a minute. All right. For every angle on the unit circle, there's a ordered pair that kind of pairs up with the angle. And then I just want to remind you that cosine of theta on the unit circle is x, and sine of theta is y, and then we can find everything else. All right, so let's do our first example. Bow. So this is the kind of problem I'm going to ask you on the next assessment. Find sine of 240. So you don't have to draw a diagram, but I'm going to draw a diagram. So where does 240 degrees live? So we have 180 plus 60 takes us to 240. So on the unit circle, 240 is in the third quadrant. So I want to know on the unit circle, what is this point for 240 degrees? So 240, remember 240 references 60 degrees. That's important. So now I'm going to go to 60 degrees. 60 degrees lives about there, and those coordinates are 1/2 and root 3 over 2. So if 60 degrees has a point at 1/2 and root 3 over 2, then my little rectangle, that's going to be third quadrant, negative 1/2 and negative root 3 over 2. Now right now you're thinking, I can just go to my picture that I've already drawn and just find the answer, Spires. You're making this hard. No, because ultimately you're not going to have that little cheat sheet. So I'm showing you to this day how I process a problem like this, and my hope is over time you just get faster and faster. So sine is my y-coordinate. At 240 degrees, the y-coordinate is negative root 3 over 2. So sine of that angle is negative root 3 over 2. Bam. Okay? Skirt. Next problem. Cosine of 180 degrees. Ooh, I like this one. 180 takes me there. That point on the unit circle is negative 1, 0. So I found the point at 180. Cosine by definition is the x value. So cosine of that given angle is the x-coordinate, and the x-coordinate is negative 1. Boom, done. So cosine of 180, negative 1. Sine of 180, 0. And I could find tangent cosecant, cotangent if I needed to. Takes us to the next example. Bow! Tangent of 7 pi over 4. All right, let's draw our unit circle. So remember, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. When I see something pi over 4, it's one of them's. 7 pi over 4 takes me into the fourth quadrant. So that means I am root 2 over 2, negative root 2 over 2. Now, that's what's going on in my brain when I see 7 pi over 4. You're kind of looking at your circle that you've drawn earlier in the lesson, and you're thinking, okay, that's my reference. All right, so here we go. So, tangent, by definition, is y over x, which in this case is negative root 2 over 2 over root 2 over 2. And you're going to see this over and over. Anytime you take tangent of a 45-degree reference, it's always going to be a number divided by the same number plus or minus. So it's kind of nice. Negative root 2 over 2 divided by root 2 over 2 is negative 1. Oops. Negative 1. Final answer. Okay? You find the angle, therefore the corresponding point, and then the trig value at the angle is with respect to x or y. Bow. Tangent of 510. Now, we finally use reference angles and coterminal angles. So I know 510 is more than 360. So 360 degrees, right? And then some. So I'm going to take 510, subtract 360. That gives me 150 degrees. So 150 degrees takes me to there. So I want to make this clear right out of the gate. If I take a 510-degree angle and then I subtract 360, that doesn't change my x and my y. Therefore, that doesn't change tangent of 5. So I can now find tangent of 150 degrees, which is going to be y over x. Well, tangent of 510 degrees is the same y over the same x. So these two values will be exactly the same. So in every single trig function, if you convert the input, if you convert the angle to a coterminal angle, you will not change the output. The output will not change. Okay? So for every trig function, if I give you some ridiculously large or negative angle, you can find the coterminal angle between 0 and 360 and continue on your way. So now we're trying to find tangent of 150 degrees. Remember, 150 is my reference of 30. So what's my reference of 30? When I think of 30, I think of root 3 over 2, 1/2. So now I'm over here, which is going to be negative root 3 over 2 and 1/2. So tangent of 150 is 1/2 over negative root 3 over 2. You're going to see these numbers being divided over and over. The 2's cancel out. We've seen that before. Okay, I need to rationalize, which will be root 3 negative root 3 times root 3 is negative 3. So you can leave your answer like that, or you can put the negative out front, doesn't matter. But I do want you to know this. Every time you have a problem that is 1/2 over root 3 over 2, it will always equal root 3 over 3. And then, of course, if there's a negative on top, the answer is negative. Or if they're both negative, then the answer's still positive. But I just want you to be thinking 1/2 over root 3 over 2 is root 3 over 3, and then you can kind of deal with your signs. You're going to see these same numbers over and over. All right, so tangent of 510 is equal to tangent of 150, which is answer. All right, example 7. Cosecant. So I just want to remind you, as soon as you see cosecant, scoop, 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 sine. This is what you're thinking. Sine of same angle. Doesn't matter. As soon as I find sine, I will invert it, and I will find the reciprocal to find cosecant. So cosecant is simply a one extra step sine problem in my mind. So negative pi over 6. So pi over 6 is here, or 30 degrees. So negative pi over 6 is here. So just to remind you, you can convert negative pi over 6. You can add 2 pi and make it positive. That's fine. But when I think of, if I know where pi over 6 is, I can easily find negative pi over 6. Negative pi over 6 is, if pi over 6 is in the first quadrant, then negative pi over 6 is in the fourth quadrant. So the only difference here is instead of root 3 over 2 up 1/2, it's root 3 over 2 down 1/2. So sine of negative pi over 6 is my y value. So therefore cosecant is going to be the reciprocal, and the reciprocal of negative 1/2 is negative 2. Final answer. Now, once again, guys, I'm blasting through these. You're going to get into Delta Math, and you're going to do your absolute best to not just look at the reference sheet, put in an answer. Look at the reference sheet, put in an answer. Look at the reference sheet, put in an answer. You're going to really try to conceptualize each and every one of these problems. All right. Secant, 15 pi over 4. Remember, I don't like secant. I'm thinking cosine. Okay, now I see something pi over 4, I'm already thinking 45 degrees. I'm already thinking a whole bunch of root 2 over 2 kind of numbers. But 15 pi over 4 is too large. So I've got to take 15 pi over 4 and subtract 360. Now remember, 360 is 2 pi. So I'm going to subtract 2 pi. Now remember, you're going to try to find other ways of doing this because you might want to convert to degrees. I'm going to leave it as this. 2 pi is 8 pi over 4. Okay? So I took 15 pi, which was way too large. It's multiple rotations, or at least one or more rotations. One rotation and then some. So 15 pi over 4 minus 2 pi. 7 pi over 4. Now I know where that lives. So 7 pi over 4. Now originally it was here. That's 15 pi over 4. But we subtracted we subtracted 2 pi to take it into something we can get a handle on. So I do want to make this clear. Cosine of 15 pi over 4 will equal cosine of 7 pi over 4. We're not saying the angles are equal. We're saying the value of cosine is the same. And remember, the value of cosine is, so this is root 2 over 2 and negative root 2 over 2. Cosine is my x value. So the x value here and the x value here, same. It's the same point. Two different angles, but they have the same terminal location, same terminal side, same x value. So my answer is root 2 over 2, my x value. But we were asked to find secant. So just a reminder, secant is the reciprocal, which is 2 over root 2. Now I'm not going to write 2 over root 2 anymore. I'm going to rationalize this one time. 2 root 2 over 2 So make a note. The reciprocal, and this is kind of crazy. Numerically, it just seems weird. The reciprocal of root 2 over 2 is root 2. Those are reciprocals. So for all of the sine or cosine problems that are root 2 over 2, secant and cosecant are always going to be root 2. Okay, it's kind of strange. All right, example 9 and our last example. Not as ugly as it gets, but pretty ugly. Okay, so 13 pi over 6 is too large once again. So I'm going to first do 13 pi over 6. I need to unwrap this. It's too large of an angle. So I hope as you've gotten some practice with this. Otherwise, you've been doing a whole lot of converting to degrees, which over time will actually be a much longer process. So you want to get comfortable with what I'm doing here. 13 pi over 6. 12 pi over 6. So 2 pi is 12 pi over 6. Remember, I did a bunch of these in one of those first videos. So 2 pi in terms of a fraction with 6 on the bottom is 12 pi over 6. 13 pi over 6 minus 2 pi is pi over 6. So hey, this problem winds up being pi over 6 or 30 degrees. So just a reminder, pi over 6 is 30 degrees. So this is the same as tangent pi over 6, which is the same as tangent of 30 degrees. All of those are the same. So now, what are my coordinates? My coordinates are root 3 over 2 and 1/2. Root 3 over 2. Oh no. Help me. Tangent is your y value divided by your x value. So that's going to be 1/2 over root 3 over 2. Remember, that's 1 over root 3, which we've said a couple times now is root 3 over 3. So I just want to remind you, anytime you have 1/2 over root 3 over 2, bam. So guys, we are done. 42 minutes. This was a big one. This is a big video. Now, a lot of what I've shown you is where stuff comes from, but you have to, very soon, in the next few days, I'd say about 3 or 4 days after watching this video, you should be able to take this diagram that you see right here, this unit circle, and you should, without any help, be able to label every single point of importance which correlates to all of my multiple of 30, 30 degrees, 60, 90, right? 120, 150, 80, all my multiples of 30 and 60, 60. All of my multiples of 45, remember my 45s are those ones that are in the middle, in the middle, in the middle, in the middle. So you should know all of the angles in the unit circle, multiples of 30s and 45s, all of the points, and then you should be able to find sine, cosine, tangent, cotangent, secant, cosecant of any of those angle values. Reference angles and coterminal angles, we're kind of bringing it all together. So guys, 44 minutes, not terrible. As always, practice the problems. You took good notes. Now practice the problems. And as always, come to class ready to ask lots of questions. Be safe.